Every day, enormous factories transform mountains of green sugarcane into the bright, white crystals found in kitchens around the world. But how does a fibrous tropical plant become clean, refined sugar with consistent color, purity, and texture at massive scale? The journey begins in the fields, continues through crushing, boiling, crystallizing, drying, and ends inside fully automated packaging lines. Today, we step inside a modern sugar factory where raw cane is transformed into one of the world's most familiar ingredients. Sugarcane is a tall tropical grass grown in warm regions where sunlight, rainfall, and fertile soil help build natural sucrose. Inside each stalk, sweet juice is locked within tough fibers, protected by a hard outer rind and dense internal structure. For centuries, sugarcane has shaped trade, agriculture, and food production, becoming one of the most important crops on earth. Modern sugar mills must work quickly because once cane is cut, its sweetness begins to slowly decline with time. This is why harvesting, transport, and factory processing are carefully coordinated, keeping the raw material as fresh as possible. The process begins with rows of mature sugarcane being harvested by machines or workers, depending on the region and field conditions. Cut stalks are gathered into large bundles, loaded onto trailers, and prepared for rapid delivery to the nearby processing plant. Heavy trucks arrive at the factory entrance, carrying towering loads of sugarcane from farms spread across the surrounding countryside. Before unloading, each truck is weighed, logged, and sometimes sampled to estimate sugar content and incoming raw material quality. From here, cranes, hydraulic lifts, or conveyor systems move the cane into receiving areas designed for continuous factory flow. At this stage, speed matters. A delay can reduce juice quality and affect the efficiency of every step that follows. The freshly delivered cane carries soil, leaves, stones, and field debris, all of which must be removed before crushing begins. Powerful washing systems spray the stalks with water, loosening mud and cleaning the surface before the cane enters preparation lines. Conveyors separate loose trash, while operators and sensors monitor the flow to prevent unwanted material from reaching heavy machinery. This cleaning stage is critical because stones or metal fragments can damage rollers, blades, pumps, and expensive factory equipment. After washing, the cane moves toward rotating knives and shredders that open the stalks and expose the juice-filled fibers inside. The goal is not to make powder, but to break the cane enough for efficient juice extraction in the next stage. This is where the transformation truly begins, as shredded cane enters massive crushing mills built to squeeze out sweet juice. Heavy rollers press the cane repeatedly, forcing golden juice out while the dry fibrous material moves away from the mill. In some factories, hot water is added during extraction, helping wash more sugar from the crushed cane fibers. The remaining fiber, called bagasse, is not waste. It is often burned to produce steam and power the factory. Fresh cane juice is cloudy, greenish-brown, and filled with tiny particles, minerals, waxes, and natural plant compounds. Before sugar crystals can form, this raw juice must be clarified, filtered, and stabilized through carefully controlled treatment. Lime is commonly added in controlled amounts, helping impurities gather together so they can be separated more easily. The juice is heated in large tanks, causing unwanted solids to rise, settle, or bind into heavier particles. Clarifiers separate the cleaner liquid from the muddy residue, leaving a clearer juice ready for concentration. What remains is still mostly water, so the next challenge is removing moisture without burning the valuable sugar. The clarified juice enters evaporators, where heat and vacuum systems concentrate it into a thick, amber syrup. Using multiple evaporator stages saves energy because steam from one vessel helps heat the next vessel in line. As water disappears, the syrup becomes denser, darker, and much closer to the point where crystals can finally form. The concentrated syrup then moves into vacuum pans, where boiling happens under reduced pressure to control temperature and texture. Seed crystals are introduced, giving dissolved sugar a surface to grow on as the syrup continues to thicken. Inside the pan, millions of tiny crystals slowly expand, suspended in a heavy mixture known as massicute. Operators control boiling time, pressure, and concentration carefully because crystal size determines the final appearance of the sugar. When the crystal mass reaches the correct consistency, it is discharged into mixers and prepared for separation. The massicouite enters centrifuges, high-speed machines that spin rapidly to separate sugar crystals from the dark molasses syrup. Molasses drains away through screens, while the crystals remain inside the spinning basket, becoming cleaner with each cycle. In many factories, crystals are washed with a controlled spray of water or steam to remove remaining surface color. After centrifuging, the sugar is lighter, cleaner, and more recognizable, but it still contains moisture and uneven crystal sizes. The damp sugar moves into large dryers, where warm air flows through the crystals and removes excess moisture. Drying must be carefully balanced. Too much moisture causes clumping, while too much heat can damage color and quality. From the dryer, the sugar passes through cooling systems, bringing the crystals to a stable temperature before screening. Vibrating sieves separate the sugar by size, removing oversized lumps and fine dust from the main product stream. Uniform crystals are important because they pour better, dissolve predictably, and meet the standards expected by food manufacturers. Rejected lumps can often be reprocessed, while fine particles may be redirected into other sugar streams or industrial uses. By this stage, the original green cane has become dry, bright, refined sugar crystals, ready for final inspection. Quality control teams check color, moisture, grain size, purity, and flow behavior before the sugar is approved for packaging. Automated sensors and laboratory tests help confirm that every batch meets strict food safety and production standards. Metal detectors and screening systems protect the product from contamination before it enters the final packaging area. If a batch fails inspection, it is held back, corrected when possible, or diverted away from consumer packaging. Approved sugar moves into silos, where it is stored in clean, controlled conditions before being released to packing lines. Automatic dosing machines measure exact amounts into paper bags, plastic packs, bulk sacks, or industrial containers. Each package is sealed, weighed, coded, and labeled, creating a traceable product ready for markets and food factories. Robotic palletizers stack the finished bags into stable patterns, preparing them for warehouse storage and long-distance distribution. From the factory, refined sugar travels to bakeries, beverage plants, restaurants, supermarkets, and homes across entire regions. What began as a rough green stalk ends as a precise white crystal, shaped by heat, pressure, timing, and industrial scale.